What is statistical process control? This, or SPC, allows for a given process that needs maintaining or improvement to continuously run smoothly and become better over time. This task can be accomplished through statistics in order to optimize money, resources, and time. Though not a major portion of overall manufacturing and engineering, SPC is a very beneficial method for resource usage, financial, and time optimization. There are multiple charts that are utilized in the SPC according to the parameters at hand. Charts like these include X-bar and range, individual moving range, and X-bar and standard deviation charts. Of all engineering disciplines, industrial engineering is the field of study that utilizes this concept to the max. With this, they can not only constantly keep track of processes being supervised, but have a chance to predict and avoid possible failures that may happen sometime in the future. This is a more detailed chart of how methods are determined in order to assess the situation at hand. For further SPC application, a commonly used chart that is used for a spectrum of different operations in many areas is a P chart, which specializes in binary scenarios. The four fundamental parts of this chart include the mean of the dataset, this green line right here, the actual dataset, obviously shown by the orange line here, the lower control limit, about 3 sigmas away from the average, and the upper control limit, 3 sigmas away as well. Companies like Honda use P charts to check almost every aspect of the cars they produce, like the minimum amount of speed necessary for one of the doors to fully close. With an individual chart variation, Honda was able to identify a door that took too much speed to close, and after some investigation was conducted, found the problem to be the specific striker installed on the door. The reason why the upper control and lower control limits are 3 sigmas apart from the mean is due to the fact that it is the Goldilocks of standard deviations away. 2 standard deviations away and we'd have too many false alarms. 4 standard deviations away and we'd never be able to catch the special causes or any errors that may occur throughout the process. This is a quick video of me making my own P chart. Not much to it. Dates and certain measurements within those dates. The means, of course, being consistent with all the measurements, and the upper control and lower control limits being calculated. And this is the resulting example P chart.